Hi everyone, in this video we will be discussing about acidity of carboxylic acids. Acidity of carboxylic acids. What are carboxylic acids? Carboxylic acids are chemical molecules having carboxyl chemical moiety. There are two main types of carboxylic acids: aliphatic carboxylic acids and aromatic carboxylic acids. In addition, there are many subtypes of carboxylic acids such as monocarboxylic acids, fatty acids, dicarboxylic acids, tricarboxylic acids, and so on. Now let us talk about acidity of carboxylic acids. So what are acids? The acidic nature of chemical molecules can be explained by many different concepts such as Arrhenius concept, Lowry-Bronsted concept, and Lewis concept. Okay, these are the concepts are very useful to explain the acidic property of the chemical molecules. In general, what are acids? Acids are the chemical molecules which are capable of providing protons upon dissolving in water or attracting electrons during the chemical reactions. Now we know what are carboxylic acid, what are acids in general. Now let us talk about the acidity of carboxylic acids. When you dissolve the carboxylic acid in water, the carboxylic acid will be dissociated as carboxylate ion and H3O plus, as I am writing over here. Carboxylate ion and H3O plus. So upon dissolving in water, the carboxylic acid releases the proton, so it can be called as acids. So using these reactions, the association constant of acid can be calculated. Ka is association constant of acid. Association constant of acid. This can be calculated on the basis of these chemical reactions. So Ka is equal to concentration of H3O plus and concentration of RCOO minus divided by concentration of RCOOH. So from this expression we can calculate the pKa. pKa can be used to understand the strength of the acid. The pKa can be calculated from the Ka. pKa is equal to minus logarithm of Ka. So if you know the Ka, you can calculate the pKa. If you know the pKa, you can calculate the Ka. So from the pKa you can also calculate the Ka. Ka is equal to 10 to the power of minus pKa. So if you know the Ka, you can calculate pKa. If you know the pKa, you can calculate the Ka. So now what is the use of PKA values? So the PKA values can be used to understand the strength of the acids. Strength of acids. If pKa values is larger, then it indicates that the acid is weak. If the pKa value is small, the acid is strong. So the pKa values and the strength of acids are inversely proportional to each other. So now let's see how the pKa value is affected by a carboxylic acid. the general structure is RCOOH. So depending upon the R group, the dissociation of COH will be affected. If the R group is electron donating group, the strength of the acid will be reduced. If the R group is electron withdrawing group, the strength of the acid will be increased. This is because of simple chemistry. When the R group is electron donating groups, what happens is it provides the electron to the carboxyl moiety. Upon dissolving the carboxylic acid in water, the RCOOH will be dissociated as RCOO minus and H plus. Now the carboxylate ion will be destabilized by the electron donating groups. When the carboxylate ion is destabilized, then it will become a weak acid. In the case of electron withdrawing group, the carboxylate ion will be stabilized. Because of the stabilization, the acid strength will be increased. Actually, the carboxylate ion can be written as RCO minus O, and this is resonance structure minus. This carboxylate ion should be stabilized. So the electron donating group destabilizes the carboxylate ion. Consequently, the strength of the acid is reduced. The electron withdrawing group stabilizes the carboxylate ion. Consequently, the strength of the acid is increased. Now let's see the electron donating groups and the electron withdrawing groups. In general, in the periodic table, when you move from left to right, the electronegativity increases. When you move from top to bottom in the periodic table, electronegativity decreases. So, in the periodic table, what we have right now, fluorine is the element present on the top right. So, fluorine is the most electronegative element we know to date. Now, the fluorine belongs to the halogens groups. So, what are the elements in the halogen groups? Fluorine, chlorine, bromine, iodine, and so on. So, the electronegativity of fluorine is much higher than chlorine. The electronegativity of chlorine is higher than bromine, is higher than iodine. So what is electronegativity? Electronegativity is a property of the element or the chemical moiety capable of attracting electron from the groups or element that is attached with that element. Okay. Now, so the fluorine, chlorine, bromine, iodine are electron withdrawing groups. Now consider a formic acid, HCO, simple carboxylic acid, formic acid, right? Instead of H, you can put the CH3. This is acetic acid, right? So in the acetic acid, all the three hydrogens can be replaced by the fluorine atoms. So CF3, COOH. So this is trifluoroacetic acid. This is formic acid. This is acetic acid. This is trifluoroacetic acid. Of these three, which is the stronger acid? Which is the weaker acid? So now the strongest acid is CF3 because we have the three fluorine atoms in the alpha carbon atoms which is attached to the carboxyl groups. So of these two, which is stronger acid? Formic acid or acetic acid? Now let's have a longer series than this one. You remember this series in order to understand the strength of the acids. So what we have? Fluorine, chlorine, bromine and iodine. I am going to add few more groups here, few more groups here. Now CN is stronger than fluorine. NO2 is stronger than CN. CF3 is strongest of all these elements and groups. Now, iodine is stronger than phenyl groups. Phenyl group is stronger than alkyl groups. You remember this series. Okay. So when you move from left to right, the electron withdrawing tendency is decreasing. When you move from right to left, the electron withdrawing tendency increases. Okay. So in other words, when you have this group attached to the COOH moiety, the acid strength will be much decreased. When you have this group attached to the COOH group, the acidic strength will be increased. Now let us discuss about the strength of the acids. Consider the formic acid HCOOH and CH3COOH. So of these two, which is stronger acid? Of course, formic acid is stronger than acetic acid, because in this acetic acid, in this case, so we have methyl group, alkyl group attached to the carboxyl group. So alkyl groups, the methyl group is electron donating, it has electron donating tendency. Because of electron donating tendency, the carboxylate ion generated from this acetic acid will be destabilized. Because of that, the acidic strength will be decreased. Okay, now let us consider another example. So CH3COOH, CF3COOH, CCl3COOH. So of these three acids, which is stronger acid, which is weaker acid? So now we have the alkyl groups over here. It is attached to the carboxylic chemical moiety. Here we have CF3, here we have Cl3. From this series we know that fluorine has higher electronegative property than that of chlorine. So obviously CF3COH, trifluoroacetic acid, will be the strongest acid of these three, and acetic acid will be weaker, and the CCl3COH will be moderate acid. Now let us consider another example. So consider the formic acid, simple one, COOH. Now instead of H I put CH3, alkyl group, CH3COOH. Now instead of H I put the phenyl groups, COOH. So in all these three, COOH is common, carboxylic acid. Now here we have H, here we have CH3, here we have phenyl. On the basis of this series, we can easily rationalize that formic acid is the strongest acid of these three, and acetic acid is the weakest acid. So the order is formic acid is stronger than benzoic acid, which is stronger than acetic acid. I hope you understand what are carboxylic acid, what is acidity of the carboxylic acid, and how the electron withdrawing groups and the electron donating groups influence the strength of the carboxylic acids. Thank you so much.